Good morning, I'm going to do a little showcase of a prototype that I've been working on. It's a 2D platformer, inspired by Wario Land 3, that's the main reference that I have, which means things like enemies not hurting you, they're just kinda bully you or are in the way. You can see that when I run into the enemy I just get bounced away, right? So, let's go into the basics. It's a 2D platformer, so you move into one axis. Of course you can jump. The speed at which you can move while in midair depends on your facing direction. There's a lot of nuances like that in the controller. And here are some slopes, so let's climb them. So you have seen that when you climb the slopes, part of the mesh has disappeared. It represents the feet collision. Of course it's all programmer art. When I have final art, this will be much different and nothing will disappear, of course. The idea is that when you go into a slope, your cutter it's a capsule controller, but when you are on flat ground, it becomes a bullet controller. And I want it to be a bullet controller so that I can have nice edge detection, like in this case. And, well, I fell down. Okay, let's go back up. So yeah, there is edge detection for falling automatically, and it works even in edge cases like this thin pole here. So let's try that again. Oh, sorry, it's a bit hard to get on. Yeah, there we go. So you can see it works on both sides. So, just like in Wario Land 3, instead of the usual hazards like enemies that take health away from you, we have cartoon violence. So that blue area represents some spikes. Of course at the moment it's all programmer art. But when you touch the spikes, you get bounced into the opposite direction, and there's some little hops and then some recovery that happens as part of the sequence. And the idea is that when something happens to you, your cutter changes states, and in each state it has access to different cutter controllers, which means a different list of behaviors are running. So your cutter responds to inputs in different ways, or something happens automatically, like those little hops. The other cutters are also using the same classes for implementing their behaviors, so everything I implement for one character is perfectly reusable for another. Enemies also carry hazards with them. So you have seen this little guy has prickled me. I can still bump into it, but if I fall on its head, I get prickled and I get pushed back. So now the enemy becomes a different kind of obstacle because it wants to prickle me. So I need to find a way to get past it. The other hazard I have implemented so far is fire. It's just a clone of the fire mechanic in Wario Land 3. So, this red area here represents fire, and when I touch it, my character is on fire, and it starts running automatically. I can jump, it's the only thing I can do, and when I touch a wall, it turns to run in the opposite direction. And after a while, it goes into the on fire in flames state, representing the character completely engulfed in flames. I move more slowly, and then my recovery state, in which I cannot move. So, let's try that again. And we're on fire once more. I can still get prickled while running on fire and get launched into the opposite direction, and after that, it'll go back to on fire running with the same time left. Internally it's a funny state machine. Some states allow you to go into other different states or not, and when an interruption like this happens, it remembers data from the previous state so that it can be resumed. We also have ladders. You may go up or down, you can go back into the ground, you can also plummet so that you accelerate the downwards direction. You can drop from the ladder, you can also jump out of the ladder, and of course, climb all the way up to the top. Enemies can also carry fire, so we need to wait until this one burns out. In the Wario Land 3 games, fire is used as a puzzle mechanic, so maybe during the in flames state you need to burn some blocks or something of the sort. We will have that eventually. So let's go back up. Okay, let's demonstrate some ladders. Ladders have a collision at the top, so that you can have a limit on how far you can go, and you can jump from ladder to ladder, and we are all the way up to the top. And now this is where things get interesting, because so far this was another round-the-mill 2D platformer, right? You move into a 2D space, but this space curves. And this is not something super new. There are already old games that do something like this. I'm thinking of, for instance, Pandemonium, a very old game. But I think it adds a new spin into the Metroidvania formula, which is the kind of game that I want to make. Because if you think about it, Wario Land 3 is secretly a Metroidvania, and I just love those kind of games. So the way this works is by really curving the space. If a 2D game happens in a tube, I'm twisting and turning that tube. Oh, and by the way, I almost forgot about the one-way platforms. I think they also deserve to be mentioned, but that's all about the standard 2D platformer mechanics. Let's go back to the curves. So I'll explain later how it works internally, but the idea is that I can bend the space into any direction. And when I say any, I mean any direction. The idea is that I am changing the up direction as well as the right direction for the standard curves. And at any given point in the space of the game, the up direction is one or another. I know that the transition at the moment is a bit choppy. I already know why this happens, and I'm already working on a better implementation, but the idea still stands. It's just some cool gimmick that I came across while trying to just do the regular curves, and I think it deserves exploring because you can do a lot of psychedelic effects, like this corkscrew section of the game. You can also change the angle to give strange effect, like this Dutch angle here, or maybe you can climb impossible objects, like in the following section. Of course, there is also a design challenge to communicate this to the player properly. But here goes. Yeah, you can climb this section. And I think that's gonna be the gimmick of the game, what's gonna make it interesting and maybe stand out. And it does have some deficiencies at the moment, but I think it has a lot of level design potential. Like, you could implement Mario Galaxy planets with this. Of course, Mario Galaxy probably works with gravities and forces, but I don't know, I think there is a lot of potential in this, and I want to get it right. I think that I'm already heading into the right direction with the implementation. I can't wait to show you guys. And that's about it, really. One last point about this is that since I'm curving the level, after all that twisting and turning, the levels can close in into themselves by just going towards the right, like in classic 2D platformer games. So yeah, we can climb this final section, and we are here at the top, and after that, we can be back at the very beginning. So yeah, thank you for following me through this level, and now let's take into how everything works. Now let's look into some implementation details of this prototype. It's made in Godot. I wanted to try something different than Unity because I already have a lot of experience with Unity and I wanted to try a new engine. I could also have chosen Unreal Engine, but I didn't feel like it was a great fit for the kind of game I'm intending to do, although it could have been a good option as well. I just wanted to try Godot and see what it can offer as a free open source game engine, and it does have a lot of shortcomings and limitations, but it's getting the job done so far. So let's jump into the most interesting part now, which is the level curve. You can see this white curve going around the level, and that's what's defining it now. You can see all the control points, and in the corkscrew section I'm using the tilt of the curve so that the up direction follows the corkscrew. And this is what the curve looks like in this section. And that's what changes the up direction of the level as you go up through this curve. So the way it works, it's by using the curve to create a tunnel or a tube that defines the reference axis along these curves. It's a tunnel made of warped polyhedrons. A polyhedron is a six-sided shape, like a cube or a dodecahedron, but with an angle in the vertices. And in this case, they can also twist a bit. Each baked segment of the curve produces a plane by extending along its particular axis, and then these are joined together to form the tunnel through which you move. You can also see in this section that if many segments produce the same polyhedron, they are joined together just for performance reasons. So yeah, I'll explain it again so that it's more clear. So I get the curve, and then each segment of the curve produces a polyhedron that is obtained by getting every point and extending that point into 4 different directions, up, down, left and right, and then I just group them together, and that's what defines the level. If you are within that tunnel, you are in the level, and that changes the direction of everything you do, and that's how it works. So as you have seen before, at the moment the system has some faults. When the level is twisted a bit too much or a bit too crazy, like in here, the game is a bit too choppy, so let's see why that's happening. I can actually remove these lines to find out. And you can see that when the curve is flat, everything is smooth and continuous, just as we want it. But when we get to the crazier parts, due to tilting or changing the up direction in two extreme ways, we get these whiter shapes. Those are tell, that means that the segments are overlapping. And in here we can see that it's a bit hard to tell if we just turn the lines back on. But we can see them here. It's even more obvious in this section. Let's turn the lines back on. We can see that every segment is overlapping, which is why the results are a bit confusing. Because what's happening is that when you move from one segment to the next in this section, you are not entering the leftmost phase of the segment, but just in the middle of it, which is causing this jumpy behavior that we have seen. So I'm already iterating on this system to produce a better result. Maybe interpolating every segment you're in works, or maybe I need to author this differently by using more than one curve to fine-tune these edge cases to guarantee there are no overlaps, or probably a mix of both ideas. This is still a prototype coming out of expanding on my initial implementation of the flat curves, which do already work. There's also design and art challenges associated with this, like finding a thematic reason as to why the levels would curve, or how does a player know that the level will start doing crazy things, whether you will be able to climb a specific vertical or not, and so on. There needs to be some sort of language that communicates that to the player. But since I haven't even planned what my game is about, who my main character is, where they are, this is just something that needs to be solved in the future. I'm not worried about it. At the moment I'm just kicking out with the technology and overcoming challenges that I put to myself. I'm just having fun. I hope that you're finding this fun as well. So, this is our main character here. Hello! Oh, too close. So let's look into how he works. So as I mentioned before, the character can be many different states, such as normal, on fire running, on fire in flames, and so on and so forth. Each state might have specific logic and data, especially to deal with state transitions, but also each one gives access to a different controller. So whenever a character enters a state, the corresponding character controller is activated. A controller is just a set of behaviors that run, one after the other, processing the input to create the complete movement of the character at that moment. So, in the normal state, the character may jump, is affected by gravity, may move in midair, the phase direction is set, does the horizontal movement, handles the slopes by modifying the horizontal speed, and it may also decelerate by default when there is no input. Internally, there is a component system that's shared between all the behaviors, so that they can talk to each other, or modify variables that are shared between behaviors. Think of it as a blackboard of sorts. We can see that on the fire running state, the controller is slightly different. In this state, the character runs automatically and turns on walls, so it handles the wall turning first, then overrides your input to force it to move forward, and the rest are behaviors that we had seen in the normal state, with different values. We jump, we have gravity, we move in midair. The system to set the facing direction needs to be run again, then the horizontal movement is the same as before, but now it's using an overridden input from the input forward behavior, then the slope handling, etc, etc. So that's how we get different character movement in every state. Here's the bounce hops. It has a different set of behaviors to handle that hopping that happens. And that's how it works. As you can see, it's very modular, it's very reusable, and in fact, the enemies are using the exact same behaviors. So we can go into this enemy here. Okay, let's close this one for now. Let's check its states. And we can see that in this idle state, the controller is using the same behaviors that we have seen on the main character. That way, everything that I make for the player works for the enemies and vice versa, and I can quickly create complex behaviors by mixing up these small behaviors like building blocks. And the way the enemies can make use of them is by having a different input, and that is handled by the brain, which is the actual character AI. The brain handles the input that is read by the behaviors, and it could also trigger other things. For now, it's just another state machine, although it could be something more complex if I need it, like a behavior tree, for instance. Since this state machine could get more complex than the other, it can be very hard to just edit them here in the Godot inspector. So I created a custom editor for it. And here it is. This is the brain of all those small characters. They're all using the same AI for the moment. It's very simple, it just has 3 states, but it will be already very hard to author it just by going into the Godot inspector. It gets messy pretty quickly, states reference to one another using string IDs. It'd be very prone to errors. So that's why I created this graph editor, which takes care of all those relations for me, and it's much easier to reason on and design the AI. So you can see that initially it goes into the pause state, and these are the transition conditions. They're both a random time, so whichever rolls a lower number gets to trigger the transition, which can be either patrol or turn. And then it will go back and forth from patrol and turn. So it can randomly go from patrol into turn after a random time, or also when it cannot continue. You can see that this is a composite condition check that negates another check. Can continue just checks for walls and edges, so that the character turns instead of falling. Turning just waits for a fixed time, which later could be the duration of a specific animation on the character, and then goes back to patrol. So in the beginning it just chooses what to start with, and then just moves forward and eventually turns. Very simple. For that, each state also has an assigned behavior. So the patrol just adds an input in the forward direction, and the turn state triggers the turning when the transition happens. So that's how we can build enemy behaviors by combining very simple elements. So another feature of these brains is that they can react to character controller state changes. So something external, like a hazard, can affect the character, and we want to react to that. So we can add the character controller state as part of the graph and select between the existing states. So for instance, we could react to the bounce hop state, right? Maybe this character gets mad at you for bumping into him, so we can create the angry AI state. Maybe it's just an animation showing how mad he is, and it goes into chase mode, so we can create this other state. Maybe it makes more sense to react to the bounce recovery state. There we go. We can connect these nodes which sets the transitions, and we can add a condition to it. Let's say that it's angry for a fixed time, so let's do that. Maybe it's just 4 seconds. We can add behaviors, although right now we only have continue, so let's use that one just for example's sake. So we have quickly created this AI behavior using pieces we have implemented separately. We can also go into these resources so that we can tweak them in the inspector. We can change the color of the nodes just to tell them apart. And yeah, it uses Godot built-in frameworks, so we got some features out of the box, which is nice. And that's the gist of the editor. I'm trusting it's going to save me a lot of time creating AI behavior for the enemies. So yeah, this is all I wanted to show about this prototype. Mind that it's just a prototype, it's all programmer art, the characters are ugly shapes, the terrain is just a white box prefab that I created to build things quickly, and actually it wasn't that quick to create the stage, so I already started working on a better system to build levels fast. I've also started working on improving the level curves, solve the issues with the overlaps, causing the choppy movement, so that everything is nice and smooth. Other new features in the horizon are new gameplay features, new types of hazards, new enemies, and of course there's the big Pandora's box of the art. I still don't know what the theme of my game is, what it is about. It doesn't even have a name, and I'm not a 3D modeler or animator myself, so yeah, but I want to try to do those things. Level design is going to be another challenge too. Yeah, I want to use these features to build something interesting. Level loading may become a big thing, because it's going to be an open world. There's another open art question about character facing direction, because currently they're facing in 3/4, maybe you have noticed that, and I'm not sure if I want that in the end. Maybe I'll need to implement something to handle that. and lots of other things, but the main thing in terms of technology is of course level curves. I'm really looking forward to getting this right and maybe make another video demonstrating the system in an even crazier scenario. So thanks for watching and listening. My name is Álvaro Pérez, and this was the first devlog of this unnamed project. See you next time!